One of the most ambitious questions in Egyptian math is from Rhind Mathematical Papyrus number 31. And what the question amounts to is this: that 33 divided by 2 in 13/40 is equal to 14 and 28/97. But the way they write this in unit fractions, well, the 2 in 13/47, that itself is written as 1, 2/3, 1/2, 1/7. In the next lesson, you'll see why they wrote 2 in 13/40 that way. But the answer, this 14 and 28/97, 28/97 is a very difficult fraction to write as sums of unit fractions. It's written as 14, 1/7, 156, 1/97, 1/194, 1/388, 1/679, and finally 1/7776. Sorry, just 2 sevens. You can check that this thing as a decimal does become the same thing as that as a decimal. And don't worry now about why they wrote 2 in 13/42 in this way. See that in the next lesson. Okay, I'm going to take you through the calculations that they did to get this ambitious answer. Okay, so the way we do this is we start making a chart. And we keep doubling. I'm just going to go like this. 2. 2/3 doubled is 1 1/3. Half doubled is 1. 1/7 doubled is 2 7ths. But based on the chart, the 2/n chart, 2 7ths is the same thing as 1/4, 1/28. You can look at the 2 7ths chart right here, the 2/n chart, to see that. Okay, let me just combine some things now. This 2 and this 1 becomes 4. And we got those left over, 1/3, 1/4, 1/28. Well, my target is 33, so I'm going to need to double again. And now I get 8, 2/3, 1/2. You can double a fraction that's got an even denominator by halving the denominator. But these things can be combined, and it becomes 9 and 1/6. And the 1/14 is still there. Well, I'm up to 9 now. My goal target is 33. So I double again. I get 18. These both have even denominators, so 1/3, 1/7. Now, this 18 together, this 18, 1/3, 1/7 together with the 8, with the 9, 1/6, 1/4, and the 4, 1/3, 1/4, 1/28, those three things together so far are 14. They don't usually do this, but I'm going to actually put a 14 there. This whole thing, I think, is 32 1/3. So it's getting pretty close to 33, but I can't double again. So that would get me from 8 to 16. This line here, wouldn't write it. Maybe they did it on some scrap work to see sort of where they were, so we could write it in. Now they're going to need to start going back to the beginning and going to halves to pick up the rest of this. When you go to half, you get a half. This 1 becomes a half. That becomes 1/3, 1/4, 1/14. That's actually too big It's actually bigger than 1 even. But if I go down to 1/4, I get 1/4, 1/6, 1/8, 1/28. And this thing is pretty close to the 2/3 that I need, though not quite enough, but I'm going to put a check there. And here's where I am in this problem. 14 1/4. And when I put all this stuff together, and this big expression that I have here comes from looking at this one. I only simplified it to get two things. I simplified to get a feel for where I was, and it also helped me in the doubling process. Okay, but that's where we are in this problem. Now they do something kind of, I think, interesting here. They split these two things up, and they say that this thing is 32 1/2, and the goal is to get the other half. And for these things here, they made a common denominator. They made a common denominator, surprisingly, not of 56, but a common denominator of 42. I feel like the common denominator was chosen not by looking at this, but by looking at the original 3 denominators, and since those have a common denominator of 42, that's why they did that. And they end up with 17 1/4. Now remember, they want this thing to be a half. Well, a half is 21 over 42. So we are still needing 3 3/4, which they would write as 3 1/2. They wouldn't literally write this as a fraction, but they might say parts of 42, something like that. So that's kind of where we are in this problem. We're not quite, we haven't achieved 33 yet. We got really close to 33. We're off by this very small amount. We're less than 1/10 away. Well, here's where things get really interesting. Okay, so here's where we are. And we need 3 1/2, 1/42, 40 I'm going to change this 3 into like 1 plus 2, and then I have the half on the 4th. The reason I do this is because I can actually achieve that 1/42 part pretty easily. See, if I think of it this way, you remember, this is basically a times table. This is 1 times this thing. This is 14 1/4 times that thing. So I want to know, what do I need to put here so that I could actually get a 1/42 there. In other words, I'll put a question mark there. Question mark times the 1 2/3, 1/2, 1/7 has to equal 1/42. Actually, sorry, even better, I want this to be 1 over something. Because that's what we always end up putting in here. We want unit fractions in our answer anyway, so let me just change that. Now the way it works is if I multiply both sides by this question mark, and I multiply both sides by the 42, this denominator, this one, is what you would get if you multiply 42 by this thing. Well, 42 times 1 2/3, 1/2, 1/7, That's not hard to do. I could distribute. 42 times 1 is 42. 42 times 2/3 is 28. 42 times a half is 21. 42 times 1/7 is 6. And that whole thing becomes 97. So again, I'm doing all this to pick up the extra little bit I need because I'm not quite at 33 yet. So now I stick a 1 over 97, and now I get 1 over 42. Well, I also need a 2 over 42. Well, 2 over 42 is very easy because I just have to double 1 over 97. And for that, I have my handy chart. Whoa! 2 over 97, 1 over 56, 1 over 679, 1 over 776. I'm not going to argue with that. So down here, I'm not going to put 2 over 97, but I am going to put 1 over 56, 1 over 679, 1 over 776. So now I've taken care of the 2. Now I need half. Good news, those are actually real easy, because if 1 over 42 is 1 over 97 in the left, then this half over 42 would just be, we just take half of both sides. Half of this, I double the denominator. And as far as the final 1/4 over 42, I just take half of this, where I double the denominator again, 388. And that's everything, believe it or not. If I now put these, the 1, the 2 over 42, the 1/2, the 1/4, I use them all. If there was like a 1/8 here instead of the 1/4, I'd have to go one more step and not use the 1/4. But when you take all these unusual fractions, 1 over 97, these three, this one and this one, and if you look back over here, I realize I made a mistake right here. That's 7. I think that's supposed to be a 4. This is with a 14 and 1/4. That was almost all the way there. It was just needing that 3.5, 40 seconds. And this other thing is the remaining piece. Oh, sorry. I needed the other 3.5, 40 seconds on the right here. So the 14 1/4 corresponded to this whole thing. But that was a little small. That was only 32.5 plus almost a half, but just short of a half. 17 1/4 over 42 is not the same thing as 21 over 42. So the rest of those fractions came from trying to get 3 3/4 over 42 using this as my number that I'm multiplying by, dividing by it, but this is a times table for this number. Well, that's quite a question. It's one of the most sophisticated questions in the entire Rhind Papyrus. And it is basically dividing 33 divided by 2 and 13 over 42 equals 14 and 28 over 97, written in this really complicated way. But you should be able to go through a question like this, and if I made one with different numbers, to be able to come up with this really outrageous looking answer. There actually was not, sometimes these questions is like more of an art than a science, but this one really progressed very scientifically. I doubled. 16 would get me too big. I saw where I was. I started halving. I didn't use any 2/3 in this one or 1/5 or anything, but really it just had double, half, half. And then when we saw where we were, kind of confusing, why did I use 42? Seems like they used the common denominator of what the thing I'm dividing by is. So that did require having like fractions in my numerator. Very tricky question, but I wanted to show you that. One real quick note here, so I didn't really say much about where the 17 1/4 over 42 came from. If you make a common denominator of 42 with this one, you'll get 6 over 42. These 1 over 28 plus 1 over 28 is 1 over 14, which is 3 over 42. The 1/14th is also 3 over 42. The issue is the eighth. To change eighth into 42nds, I have to multiply by 5 1/4. Because 5 times 8 is 40, and 1/4 times 8 is 2, so 5 1/4. And that's where the 17 1/4 came from. 6, 5 more from the 5 1/4, that's 11. These 3 make it 14, these 3 make it 17. But that extra quarter, that's where that 1/4 came from. Okay, so that's going to do it for that video. Very tricky. It's problem 31 in the Rhind Mathematical Papyrus.